Welcome to MathSol. In this video, we are going to look at inverse function. When we look at the term, it looks like it's a reciprocal of that function, but that's not right. But you know that we use the inverse function from the beginning of our life, like when we are starting maths in our childhood. But we never use this term inverse function. Why I'm saying that? Plus is the inverse operation of minus. Division is the inverse operation of multiplication. Even x squared is the inverse of square root of x. So we are using this. So if this is the function of x, so this is the inverse function of that x. And inverse function we always represent like f of inverse 1x. So definitely it's not like 1 over fx. That's not correct, right? It's something different. Okay, so we are not going to that direction now. So these are the things we use, but we never termed as an inverse function. In order to understand how we can get inverse function of a function, let's start with a function first. Okay, let's say we have a function of x equal to 2x plus 2. We'll check is that function or not, and we already know from our last video that how to identify function. So when we are giving x as an input, different value of x, and if it's giving us the different output like different value of y, then we are calling it as a function. So we can check it. Function x equal to 2x plus 2 is kind of y equal to 2x plus 2. We can write in this form. It's the same thing. So if we use like x equal to, for example, if I say now function of x, instead of x, if we say x equal to 0, then it gives us 2 times 0 plus 2, which is basically 2. And if I say, okay, how about if f equal to 1, or like x equal to 1, then you are getting, if I substitute what is the value of y, so we are getting 2 times 1 plus 2. I am just substituting the main function and we are getting it 4. Now if I want to show that, if you remember that correctly, if this is our function x, so what I'm trying to show, this is our domain, I mean this is our x and this is our y, and you can see for x is 0, we are getting y2. So this is our associated y for this function. And for when we are giving x equal to 1 as an input, we are getting y equal to 4 as output. Okay, so this is function. Obviously you can say it's each value of x giving the another value of y, and this is domain and range. But when we are talking about the inverse function, we are trying to reversing the process. So what I am expecting here, if I try to again showing the mapping diagram, so we are giving this 0 as an input and getting 2 output. Now I am expecting we are giving 2 input and getting 0 output. We are expecting 4 as an input and getting 1 is output. So whatever here is a domain, it is coming as a range here. So it is coming as a y. Whatever we have here output as a range, we are getting as a domain here. So that's the thing. So when we are, and this is represented as a function of inverse of x. So function x, whatever our input, function inverse of x is our output. Whatever our output here, that would be our input here. So domain is changing to range and range is changing to domain, and so we are reversing the process, and this is called the inverse function. Now let's have a look at in the graph how they look like. So if we are trying to plot these points, 0, 2 is the 1 point, we are trying to plot that point in a graph. So let's say this is our graph. This is our x-axis and this is our y, this is our y, leave it a bit more. Okay, now we have 0, 2. Where is our 0, 2? If you have 0 here, 2 mean maybe probably we can just say x, y. Okay, 1, 2. So this is our 2. Okay, 0, 2. And then 1, 4. Where is our 1, 4? So x1, y4, so it means 1 2 3 4. Let's say this is our, so roughly it is 1 4, right? Okay, now I am trying to get so if I even connect this line, so you know this is a straight line equation, and we are saying let me just adding that. Okay, we are adding that and saying that this is our function of x. Okay, now and you can even extend it, that's fine. What I'm saying that we are trying to plot these 2 points 2 0 as well. So now inverse function, we are trying to use the different color to find the inverse one. 2 0, what is 2 0? X 1 2 0, so this is the point is 2 0. 4 1, so when x equal to 4 2 3 4 4, sorry, maybe it's here 4 1, somewhere here. Okay, so 4 1, so somewhere here. So now we can add these two as well. Okay, so this is our, we are thinking this is our function inverse of x. Okay, if this is function x, this is a function inverse of x, because, and now you can have a look that this is the point and we are getting the inverse function. This is the point when we are reversing that one, domain to range, range to domain, we are getting this one. This point is the invertible of that point, okay, or inverse of that point. So it means, or this is inverse of that point, doesn't matter, it's the same. So now you can see if you make a line here, if you make a line as that one, probably it's just going like that, and we can term as y equal to x. You know, this is the line is called y equal to x, which is passing through the 0 0 and the gradient is 1. So I am just putting, this is the line that's straight line y equal to x. And if you look at clearly here, you can see that these 2 points are symmetry from about that point. These 2 points also symmetry. And if you even look at the whole function like a line, this line is the reflection of that line, or this line is a reflection of that line. So now we can define what is inverse function. So inverse function is the reflection of the function about y equal to x line. So if you consider that y equal to x line is a mirror that gives the reflection to each other, or you can say that they are symmetric about that line. So function x is, we know that it is 2x plus 2. Now if I ask you what could be the equation you are expecting for that inverse of x, I know it would be function inverse of x will be it would be minus 2, so it's a x minus 2 over 2. Then you can ask how you know that. Okay, as I mentioned, that plus is the inverse of minus operation. So when I'm undoing that and when I'm reversing the process, that plus coming as a negative and then times coming as a division. Okay, but you don't need to do in this way. We have a method of finding out that. So I'm showing you the method now. So we can use two-step process to find out the inverse function. Let's say this is given, function x equal to 2x plus 2 is given. So I can just, okay, y equal to 2x plus 2, this is the given function, and asking for inverse function. Our first step, so I can just say step 1. Step 1. Our step 1 would be changing x to y and y to x. As I mentioned before, the domain will be range and range will be domain. So what is our first step? Y will be x and x will be y. And then step 2. Step 2 would be making y subject. So I'm just rearranging the equation and making y subject. So what would be then? 2y equal to x minus 2, then y equal to x minus 2 over 2. And this is the inverse function of this. So if this is our original function, this would be our inverse, and you can see the same thing, x minus 2 over 2. So we are undoing that positive 2 as a negative 2, and then that times would be the division. As I mentioned in the beginning, we are using every day the inverse function, but we never realize it. So yeah, this is happening here. So if a function is given, you just need to follow the two steps to find out the inverse function. First step is changing x to y, y to x. So its domain would be range would be the domain, and then step 2 would be making y is a subset. So it means whenever you found the domain and range for a function, you can easily identify what is the domain and range for the inverse function. How? Because the domain of the original function would be the range of that inverse function, and the range of the original function would be the domain of that inverse function. Now I am leaving two functions for you guys to check what is their inverse function. And also you can try to plot and see are the functions and inverse functions are really symmetric about that y equal to x line or not. Unfortunately, not all functions have inverse function. The functions only one-to-one function, they have the inverse function, I mean they are invertible. But if it is many-to-one function, they are not. So what is one-to-one, what is many-to-one? I will try to explain this later, and also I will try to show you why the why the many-to-one function does not have the inverse function. Thanks for watching.